Okay, we're talking about the review for the final. Number 1 in the review packet says log base 4 of 4, and if you can't do that one, we need to just have you quit right now, and because that one's been done so many times and it's so easy that I hope you recognize it. But let's say that you didn't. You'd say equals 4 equals x, and then you'd go 4 to the x is equal to 4. Remember how to do a rewrite? You wouldn't have to do all this because I hope you already know the answer. What is the answer, by the way? 1. But if you didn't know it, that's how you do it. You go 4 to the 1 equals 4, and therefore x must be 1. All right. Some of these are really easy. They really come down to, like, can you recognize when things aren't allowed? Like, on letter F, as in Frank, you see letter F? Look at number F. It's got a negative in it. You can't have a negative there. You can have a negative in front of it. Did you know that? You can have negative log base 3 of 5. That's okay. But you can't have a negative here or here. All right. The main point that they're trying to get to in that little section is that if these two numbers can be made the same, you're in good shape. So if that's a 9, you'd make it 3 squared. That way you have log base 3 of 3 squared, and then if these two are the same, that's the answer. Okay. How about D as in donkey? You see ln of 1 over, that means it's a fraction exponent, square root of e to the 7th. All right, well, if I say ln, that's really log base e. I've trained you to, whenever you see ln, write log base e. And now this should really be e to a power. If I can just figure out what power it is, I'll be good. So what power would that be? Well, it'd have to be negative because it's a fraction. And then it would have to be a fraction. And the bottom is where the roots are. The roots are on the bottom. Remember me saying that? That's where the roots are on the bottom, and then there's only one spot left for that 7. Must be right there. And now my final answer would just be the exponent of it. All right, let's look at problem 2. Those are supposed to be different, and they are because they're expanding. Expanding means you want to make it as big as possible. So this is ln of 8x. That's a times, so you'd break that up into a plus. ln of 8 plus ln of x. All right, that's the fairly easy kind. Let's go to the kind like D as in donkey. I would assume that they'll release the answers soon. We're not like trying to hide them. It's just whether or not the packet's all been done yet. ln of cube root of x. Instead of that, right away, I'm going to write this, x to the 1/3. If you don't know that that's the cube root of x yet, you really need to learn how to write square roots as fractions, because that's way better. And I'm putting that over y to the same thing. All right, now this is a divide, which means I could expand it more and make it a subtract. ln x to the 1/3 minus ln y to the 1/3. And the last thing, it is considered more expanded if you take this and you move it down to the front. 1/3 ln x. Now I know we could probably argue that, but that's what we want you to do in expanding, is put this all the way down to the front. And since your final will be almost all multiple choice, only the R4 will not be multiple choice, you'd have to know that this is the only option that's right, is having it in front. Can't have it up there on the exponent. Okay, so there'd be the final, how to do letter D. Okay, I can start it at least. Would you agree that that ln with the whole 6th root thing, that 6th root thing could be written as a to the 1/6 power? Do you get what I'm saying? It could be like this. And as soon as I do that, that means I could put it down in front. Know what I'm saying? And now, could you agree that that's a multiply there? And therefore, I can break it up into 2 of them. 1/6 ln 4 and 1/6 ln x squared. Being added, because multiplies break up into add problems. And then the last thing is take this exponent there and don't forget to drop it down in the front too. Okay? Here, I'll go. Yeah, that's a good point. The 1/6 ln 4 is fine the way it is, plus the 1/6 ln x squared, but then when the 2 comes down to the front, yeah, it's going to have to multiply with that other 1/6. Yes? Good question. Yeah, you do have to. On the final, it's not the way I taught it to you the first time. I had forgotten that you could break that you should break those up, and yeah, you do have to. So you're right. I'm not even done with this. 1/2 ln of this 4 should really be 2 times 2 ln2 plus 1/2 ln2 plus 1/6 times 2, which would be 2/6, which would be 1/3 ln x. So why do we have to do that? Because that 4 can be expanded if it wasn't prime. You got to keep going until you got prime numbers. And that's a prime number, and that's a prime number. And x, you don't have to worry about being prime or not.
Why wouldn't you just bring the square and
Oh, I see what you're saying. Would you agree that 1/2 ln2 plus 1/2 ln2 is 1 whole ln2? Whoa, okay. I did something major wrong there. I forgot that that was a 1/6. Sorry, I'm gonna pull back up. It was a 1. Why did I get 1/2? Probably because of the 2. All right. Anyway, sorry. This is a 1/6. It's a 1/6. There's no reason that would turn into 1/2. Sorry about that. And now that 1/6 ln. Somebody was making the point, I think, that this 4. Couldn't you think of it as a 2 squared? Absolutely, you could, and it would work either way. I'm gonna show you that way this time. Whoa. Hold on. I'm going to show you, if I take that 4 and call it a 2 squared, then I can move the 2 down to the front, and 2 times the 1/6 would make 2/6, which would be 1/3. Very good. 1/3, and then it's ln2, and yeah, that worked out faster. Plus this 2 times this 1/6 would be 1/3 ln x. I did that times that. Is that right? I think that's right now. You see a problem in it? 1/6 plus 1/6 would be 1/3, right? It'd be the same thing. It'll come out the same way. All right. Oh, that was a little more complicated because I goofed up my 1/6 and I forgot to break the 4 up into 2 parts. Caught me on 2 things. Very good. Let's move on to number 3. Number 3, we're just taking logs and simplifying them. That's something we've done a bunch of times. Just remember, if it's just written plain old log, then what are you expected to do if it's just like this? Is there any way, if it's log base 10 of 20, is there any ingenious way to write that 20 as a 10 to a power? Okay. I could, if I was really going to try to fight through this further, I'd say equals x, and then I would rewrite it. Remember how the rewrite goes? That one test, almost every single problem was a rewrite. And a lot of people didn't know that or didn't think about that. I'm going to go 10 to the x equals 20, and I'm going to see if I can figure it that way. That would only work nice if these could have the same base, and I can't really make 20 into 10 to a power. I mean, I could, some decimal. So if it's like this is a tough one to start with. As far as I can see, right now, I can't think of any way I would expect you to go further with that unless you had a calculator. So since there's going to be no calculators, I guess I should check on that. I'm going to check and see if it's no calculators in the whole. I think, yes, I know. Actually, last year's we had some calculators and then some not calculators, and I think this year, that's right, I remember this now. We had a talk about this, and the decision was made to take, there was only a few on the no calculator part, or on the calculator part, so we've made it all no calculator for this year. So yeah, you aren't going to have a calculator. So like this, you couldn't do this with a decimal. I gotcha. So you're going to have answers that are going to have the numbers in them instead of, you get what I'm saying? So like let's say that your answer would normally take, cosine of 30, and then you're going to have to divide it by 17 or something like that. So I'd have to have an answer A would be like this: cosine of 30 divided by 17. I know. I'm just delivering the news to you. You're not going to get me to change everything. I didn't even write the final, but Just telling you the way it is. I do remember now that the logic seemed good. I did take the final already, and overall it wasn't awful. But there's just so much. It was actually very reasonable. The other good thing about the final is that it's still graded Marzano style. You name me another final where you can get 75% on the test and get a straight A. That's not going to be normal. Most finals you get a 75%, you get a C, right? So you got that going for you. In fact, if you want to think on the bright side, on the okay, what if I really bomb side, what's your worst case scenario? You get none of the R3s right. You can still get a C. You can get half that whole hard part of the test, you can get all of them wrong and still have a C as long as you got 75% of the easy ones right. Okay, and then if you're thinking, okay, well, I can't even get 75% of the easy ones right, what if you only got half the easy ones right? That's literally 1/4 of the problems on the final are the only ones you could answer. You'd still get a D, which isn't awesome. I know you're not shooting for a D here, but you could get a D. Now, how about this? And wouldn't you agree this is pretty likely that most kids could get about half of the easy ones right and half of the hard ones right without having to try too hard? That's a pretty typical scenario. And if you have half and half, you get a C. 75 and 75 gets you a C. So that's pretty likely that your floor is, for most of you, is you're going to probably get a C on this final as your worst case scenario. Now, most of you would rather have the A or the B. To get the A or the B, you have to get 3/4. Go for 3/4 of the easy ones and 3/4 of the hard ones. And there'll be some you'll just right off the bat, you'll look at the problem and go, I'm not getting this one right. Just let it go. Move on. That's okay. All right. There just can't be too many of those. That's what we're trying to do right now, is make sure that you're oh, by the way, on this one, what I was trying to get around to is that you could not simplify this anymore, as far as I can think of, unless this was an expanding problem, but it's not. There's nothing we can do to this problem to actually figure out the answer other than a calculator. So that's it. Leave it. Done. And that would have to be the answer on the test. Yes? I know what you're saying, and that won't necessarily simplify it. So, but see, what you're saying is this: 2 times 10, right? And then I agree we could then expand it and make it log base 10 of 2 plus log base 10 of 10. But the thing is, that's not any simple. I know this part right here then becomes 1. But I've had that discussion with the other people in the math department, and they say that's not any simpler than it was in the first place, because that's a 1 now. So it's log base 10 of 2 plus 1. I should have the plus up there. That's not any simpler than it wasn't in the first place. So on a problem like this, I would expect to see that it would just be the original. The point is seeing if kids think that 10 squared is 20, because a lot of kids are going to go, oh, 20, that's 10 squared. And so the answer is 2, and it's not. So, all right, let's move on. Let's look at condensing. Number 4, part A. 2ln x plus 3ln y. And this 2 can go up here, and this 3 can go up here, and I'm condensing, right? So now I got to squish it down into 1 log. And this is going to be ln, and then how do I put them together? If it's a plus here, what do you make it? A times. That'll be easy. X squared times y cubed. All right. I will help you individually with any of these, but I want to keep moving fast here so we can get to the part where you have open work time. In section 5, would you look at C as in cat? 5C. 5C says log base 4 of 1 minus x equals 1. All right, whenever you're solving, if you're solving, remember this. You want to get the x alone. And if you're ever stuck, rewriting helps a lot. Remember that solving test? It was out of 8 questions, I think 6 out of the 8 made you rewrite. It's either rewriting from a log to an exponential or the other way around. So let's see if you can rewrite. This one, 4 to the 1 equals 1 minus x. And again, a striking number of people can't solve that, which is scary. You just have to get the 1 out of there, then you got to divide by -1, and it's really pretty easy from there. If you need help, please ask. All right. moving on. 10F. No, 5F, sorry. Has a 10 in it. 10 to the x equals 4. That's the whole reason they invented logs, is because you couldn't get the x out of the exponent. So, what do? Use a log. Log base what? Of equals, and there we go. It's solved. Now, if I could simplify it more, I should, but I shouldn't try to expand it and make this 4 into 2 times 2 or anything weird like that. Since I can't make the 4 into 10 to the something, you know, if I can make this like 10 to a power, that'd be awesome, because then this would equal 1, but I can't. So, I'm done. All right, moving on. Let's go to the next page, look at problem 6. Ooh, there was, we're starting to get into some trig stuff there. There's a lot of trig in the tests. Remember how the first whole quarter of this class was the hard part, the trig? So we're starting to just delve into a little bit here. Number 6, does anybody remember the arc length formula? You'll have to for the final. S equals what? Theta R. You will not have that one on there on any formula sheet. There will be a formula sheet for the heavy duty trig stuff. You know what I mean? Like the ones that were double angle formulas. I don't even have those memorized. So yeah, you'll have a trig sheet for that, or a sheet for that. Yes, that's the one with the complicated angle. How many questions are there on the test? I think that there's I think there's like 20. There's some multiple of 4. There's like 26 or something. No, 4 times 5. Are you talking about just trig? Oh, just trig. No, trig is about. I'd say it's got to be in the neighborhood of half the questions on the test are trig.
Not like the ones that are really hard.
Those super hard ones that everybody had trouble with. I'd say there's only 4 questions on the whole final that hard. Okay, so don't feel like, oh, I'm going to fail the final because I won. No, there's a lot of easy trig on there too. Do you remember the first few tests on the trig weren't that bad? I mean, most of you guys got good grades on those, and then we got to the last couple and they were tough. I know. All right. Anyway, find the radius if the arc length is 40. Ooh, wait a minute. Where does the arc length go? This doesn't make any sense to me, but that's the arc length. I don't know why they called it S. But arc length is there, so I put the 40 there. And it says theta is 20 degrees. They're trying to trick you. You can't put the 20 here. Why? It's only in what? Radians. Okay. 20 degrees has to be changed to radians. That brings up a good point. How do you change 20 degrees into radians? It's either 180 over pi or pi over 180. And I think if I write it this way, you'll see pretty much right away that, wait a minute, nothing's going to cancel. You get that? And you know you're doing it wrong then. So I got to flip it over and put the pi over 180. And then stuff will cancel. The degrees cancel the degrees, and radians have no degrees in them, so it makes sense they would cancel. And then the 20 goes into 20 once, and 20 goes into your 9 times, so it's pi over 9 is your thing you should be using for the theta. So it's 40 equals pi over 9 times r, and then you have to be able to solve for r. So I'm going to multiply both sides by 9 over pi. And I just did it in one step there. Otherwise, I could have. I'll show you another way you could have done it. Let's say you just want to clear the denominator and get rid of the 9. You times by 9 first. And that cancels this. And then you divide by pi. A lot of people like to do it in 2 steps because it's easier. Get the same answer too. Still ends up being this. That's an answer.
No, what's the first? The times 49 and all of this.
This is a 9. Sorry. 9 times 40 divided by pi. And if there was no calculator on the test, you can expect they'd leave it that way because they aren't going to expect you to be able to go 300. 9 times 40 is 360. 360 divided by pi, you can't do in your head, right? No, pi is not 2. Pi is about 3.14. If you want to ask. Oh, I see what you're saying. Okay. The question is really asking about, it's not asking how many degrees, it's not asking for the arc, it's asking for the radius of the circle. So the radius of the circle is 360 divided by pi, which is a number, but I wouldn't expect you to know this in your head. All I'm saying is the test would probably have that as the answer. It wouldn't divide it out and get the decimal. Okay, let's do some more, a little bit of trig stuff here. 6, 7, and 8 are all about that same thing. Let's talk about 9. Okay, so this part or this part? The R? The S. Okay, they said in this problem that it was in centimeters or whatever. It can be whatever you want. If you're water skiing and you're going around the outside, that's a real typical question because it involves a turn in a big turn. Then you're probably talking in feet or meters, so it all depends on the problem. So if they don't give you units, then your answer is just in units. Okay, it says find the arc length, so we got to find S. So it's an S equals theta R again. I got to find this one, so I don't know that one. So they must have told me the other two. Okay, so you're talking about problem 7. It says the radius is 2 inches, so I'm going to put 2 inches right there. And the other thing, oh, I see what you're saying. It doesn't tell you if it's in degrees or radians, and that's code. If there is no degree sign, it would have to be radians. Now, I have a feeling that the teacher actually meant to put a degree sign there because 25 radians is kind of crazy, but it is good for you to know that radians don't have any units. They don't say like RAD. So my guess is that the person who put together the packet meant to say degrees on number 7. Why don't you wait and see what the key says, and then you'll know. Okay, moving on to number 9. 9A is an apple. It says find the angle theta that satisfies the given equation. Give it in both degrees and radians. Okay, I asked you to memorize this one because I said it was going to come up a lot. Living proof, it comes up a lot. Here it is again. Remember this one? How many degrees was it? 30. Very good. Now, what if you don't have it memorized? Well, then you got to set up a little triangle. Remember these? Made so many of these during that unit. And I like to have you put this. If you could have a stamp made up for the final, I would have this stamp made up, and it would have all these important points. And it would have a spot right here called, let's see, over to right 1 comma 0, and this is 0 comma 1, and that point right there, and this point right here would be at negative 1 comma 0, and this point right there would be at 0 comma negative 1. Why would that be so good? Because it answers so many trig questions. It answers where, like, is cosine positive? It's positive where all of them are positive, and also there. It answers things like, what is the sine of 90 degrees? Because here's where 90 is. And the sine is the y, which is that, so the answer would be 1. I mean, it answers lots and lots of questions. So if I were you, I'd start with one of these. You don't have to put the label with the numbers on it unless they ask you for, like, 90 or one of the other quadrantals. These are called quadrantals: 90, 180, 270, and 0, otherwise known as pi over 2, pi, 3 pi over 2, and 2 pi or 0. Okay, anyway, those are important spots. I just want to take a second to talk about it. So now, we haven't answered this question yet, though. Can I get to this question? Okay, so this question is about sine equals a half. So where is sine positive? Notice it's a positive number, right? Sine is positive right here, where all of them are positive. And there's another spot where sine is positive over here. Okay? So is there another spot where sine of something would equal a half? Could there be more than one answer to this question? Well, let's see. If I put it over here, and I make the triangle here, the opposite is 1 and the hypotenuse is 2. I happen to know that because it's opposite over hypotenuse. And if it's 1 there and a 2 there, do you remember what the other side is right here? Square root of 3. Good. So there's my triangle I'm in, and you should recognize that triangle. You should have that memorized because that's the 1, 2 square root of 3 triangle. This must be 30. And you should be able to go, cool, the answer's 30, but is there another answer? So what I'm asking you is, could this be a right answer over here? Sine of something else would also equal a half? Yeah. If this is a 30-degree angle over here, and that would make this a 1 and a 2 and a square root of 3, then there must be another angle that goes all the way from oh, what color should I use? I'll use black. From here to there, that one also gives the same answer of 1/2. And so what would that be? That would be, let's see, if we're going to do it 30, then it'd be 150. Yeah, because the total should be 180. We take away the 30. So all the way to here would be 180, but we take away the 30. So it would be 150. So I'm thinking 30 degrees and 150 degrees are two good answers. But they asked for degrees and radians. I hope you have it memorized. The 30 is pi over 6. If you hadn't memorized it, memorize it again. Get it rememorized. I'll give you a list of those good ones to know, okay? And then, wait a minute. Do you get how this is 5 times as big? So I can just go 5 pi over 6's. So it's 5 pi over 6. All right. Let's give you that list of good ones to know. 30 goes with pi over 6. What's the next one I'm going to do? Might want to make this little list for yourself somewhere.
Wait, let's just say
90. Let me get through this list, then I'll answer your question. Nope, 90's not next. What do you think's next? What's bigger than 30? But there you go, 45. Did anybody know that one? Pi over 4. Good. How about the next bit one after 45? A little bit bigger. 60. What's that one? Pi over 3. What's the next one after 60? What's that one? Pi over 2. Okay. What's after 90 usually? What is next we normally go to? 120 is possible, but then you could just double the 60 to get that if you wanted to. But normally after 90 we go to 180, and that's pi. And then 360, which is 2 pi. What I mean is, if you want 120, do you get that it's just double that one? So it's 2 pi over 3. If you want double or triple 30, let's say 120, I could triple that one and it'd still be the same exact thing. 3 pi over 6, which we reduced to, I'm at 3 30s would be 90, I'm sorry. So 3 sets of 30 degrees would give you 90, so it would be 3 sets of these, which would be 3 pi over 6, which would be pi over 2. Anyway, so you can multiply this list up is what I'm trying to say. So there's a list that should be memorized, because we do not give you those. And it takes too long. If you want to take every single problem, if you want to, you take this and times it by pi over 180 to get this. But you want some of them memorized because it just takes too long. All right, that brings up another really important point. What we just used was a 1, 2, root 3 question, and that's the 30, 60, 90 triangle. What's the other one? 45, 45, 90, and that's the 1, 1, and what? Square root of 2. But I'll give you another one that we used a lot. Does anybody remember this one? That was also a 1, 1, root 2 triangle, or a 45, 45? 2, 2, root 2. Very good. It's the same exact thing as this one. It's still a 45, 45, 90. And the ratio is still the same. But that came up a lot. And then, wait a minute, I just did something wrong. Root 2, 2. Dang it. 2, 2, root 2 doesn't work. Root 2, 2. I was just looking at the ratio going, wait a minute, that ratio isn't the same. Those ratios are the same. So, do you have to memorize it? No. But will you see a problem on it? I would bet you probably will, because that triangle came up almost as often as this one did at the end when it got hard. Yes? Okay, tangent, I can verify, is opposite over adjacent. Which problem are we doing, by the way? Okay, 9b. And it says tangent of theta equals root 3 over 3. So we're saying what angle would work to give me that ratio. So I would draw a picture. I would say, where is tangent positive? Oh, students, take calc. Tangent's positive here and here. So I'd draw 2 triangles. I would make one here, and I would say root 3 over 3. Tangent is opposite over adjacent, so that's root 3 here and 3 here. Ooh, that's not one of those ones I memorized real well, but can you recognize it? Can you tell? How about this? Can you tell that it's not the 45, 45? Then what's it got to be? It's got to be a 30, 60, 90 triangle. Okay? If this is really the 30 side, then this must, like, this is the angle that would make that 30. That would be the smaller of the two angles. Does that work for you? Does that make sense? All right, so then this, since it can't be, these have to be the same to be a 45-45, right? So it has to be a 30-60-90. Since it has to be a 30-60-90, this must be the 30 because it's across from the smaller of the two sides. All right? Okay, and then there's another one for that one, which is down here. And if this one was a 30 right there, this must be a 30 right here. And so you go, what is it all the way to there? 180 plus 30, which would be 210 degrees. So your two answers would be 30 degrees and 210 degrees. And then you'd have to convert those over into pi over 6 for this one. And this one's how many times bigger? 7 times bigger. So 7 pi over 6. All right, I hope it's coming back, even though it's maybe a little slow and painful. It should come back. Number 10. Number 10, let's talk about the angle of elevation from the top of the cathedral to a point 300 feet away. Oh, this is one of these deals. 300-foot tall thing to a point a long ways away, 300 feet away from the base of its steeple. Okay, so that's saying, how tall is it? It doesn't say how tall it is. It says that it's 300. The top of it is 300 feet away from the base of its steeple on the level ground. Oh, that was really said in a funny way, but I'm pretty sure they mean that that's 300. And this is the ground, and this is the cathedral. I don't know how to make a cathedral. That's at the big pointy top of a big building. That's there. It looks like a rocket now, but anyway. Okay, so if its angle from the base of the steeple of the ground is 60 degrees, the angle of elevation, that's a big hint. There's this angle I could be looking up from, or there's this angle I could be looking down from. And I hope you know the difference. Angle of elevation are the kind that are looking up. Okay, so the angle of elevation is the one, this one would be the angle of depression. Remember that? So we're not going to use that one. Talking about angle of elevation is that one. So this angle here is, what is it, 60? Okay, so if that's 60 and that's 300. Took a while to draw it, but now it's just trig. I can figure out anything because I got a side and an angle. So now, what do they want? They want the height of the cathedral? Do they? Yeah, that's the height. That's what they want. They want the height of the cathedral. So now I got to go. Okay, got an angle here, 60. I got a 300. So I'm going to use opposite. I'm going to use tangent because it'll be tangent. Will be opposite over adjacent. Tangent of the angle always comes next. Opposite over adjacent. Tawa, remember? Opposite over adjacent. Opposite is h over adjacent is 300. And now, on the tests, they would expect you to be able to figure out tangent of 60 without a calculator. Do you get what I'm saying? They wouldn't just times both sides by 300 and say 300 tangent of 60. Because you can do tangent of 60. Why? Because you know the 30, 60, 90 triangle. So if I know the 30, 60, 90 triangle, I can just go off to the side and make myself one. Here's a 30, 60, 90, and that's 1, 2, root 3. And if I want the tangent of 60, I go from this guy's perspective. Tangent is opposite over adjacent, which is tangent is opposite over adjacent, root 3 over 1. So this is root 3 over 1. What they would have is 300 root 3 as the answer on the test. So again, you should be able to do sine, cosine, or tangent of 30, 60, or 90s, or 45s. Because you know those triangles, and you know the quadrantals. All right. I have the feeling that your brains are full, and I can't go quite as far as I'd want to today. I would expect you, by the end of today, to be done with up through number 17. And I need to stop so that I can get you your tests back here. So that's all I got for today.